Greetings, this is Miss Jackson. I'm going to make a quick video going over some of the extra practice that I sent home this week. I'm going to start on this Foundations of Numbers Day 1, and I'm going to start with problem 3, 66 minus 28. In class, we're learning about place value. We're not really working too much on addition and subtraction yet. However, throughout the year, I see kids make the exact same mistake with subtraction every time. And so I want to go over what that is. Typically, when a kid sees a problem like this, they will set it up in the standard algorithm. From there, they start subtracting in the ones column, which is correct. And typically, if a kid makes a mistake, this is the mistake they make. 6 minus 8, and they put down 2. And then they move to the tens column because they're real proud of that 2. And they are sure that that 2 is correct. And what they'd say is, in the tens column, 6 minus 2 is 4. They triumphantly write 42 there, and then it's counted wrong because the answer is not 42. Usually when kids are making this mistake, it's because they aren't really thinking through what's happening in the place values here. It's a very abstract thing, the standard algorithm. It's hard to visualize what's happening. And so when kids are struggling with that, one thing we can use, and there are a lot of things we could use, but one that I like to use are the base 10 blocks. And I'll show you what that looks like. So here I'm going to reset up the problem 66 minus 28, but I'm going to use base 10 blocks to represent it. Okay, I've represented the number 66 with base 10 blocks, and what I'm going to do is just divide this into a place value chart and label it. Okay, from this 66, we need to take away 28 things. If we start in the ones column, as soon as we start trying to take away 8 ones, we realize very quickly that we cannot do that because there are not 8 ones here. We only have 6 ones. Once the kids see that, they know the solution to that problem is that they need to go to the tens place and they need to take one of these tens and move it back to the ones where it came from. And when we do that and unbundle it back into ones, that is going to give us plenty of ones to take 8 away from. So now I don't have 6 tens anymore, or 6 ones. I now have 16 ones in the ones column. I no longer have 6 tens because I took one away and gave it back to the ones. I now have 5 tens. We can work the subtraction problem from here. 16 minus 8 is 8, and 5 minus 2 is 3. 38 would be the correct answer. If you have a child who's working on these problems and you notice that they're struggling or they're getting it wrong again and again and again, it does not hurt to have them draw a picture. Not everyone has base 10 blocks at home. Very few people have base 10 blocks at home. Not everyone has access to one of these apps where you can manipulate these base 10 blocks, but everyone can draw a picture of base 10 blocks and the kids know how to draw them. So I would just have them draw the picture to represent what they're doing so then they can visualize it. The more they do that and visualize it, the better they get at it, and then eventually they don't have to have the pictures anymore. So I'm going to erase that. And now let's move on to number 5. I'm not going to answer every question on here, and if I don't answer something that you still have a question about, feel free to reach out to me and I will help you the best I can. Number 5 says, write the numbers in word form and represent their value using base 10 blocks. Well, the kids know that if we want to take a number from standard form, which is what's represented here, to word form, we read the number out loud and write down every single word we say in order. So if we read this number, it says 1028. So I'm going to write down every one of those words in order. I didn't add anything. I didn't take anything away. I didn't move the order of the words at all. I just wrote down exactly what I said as I read it. No matter how big the number is, if you just write down what you say, you're going to be in a good place. 1028. Now, to represent this with base 10 blocks, you have to start with the thousands place. There's one of those. To represent 1000, we use a cube. Who did not love drawing that in school? Your child's cube may not look very much like a cube, but if they know that that's a 1000s cube, that's great. From there, we go to the tens place. We have 2 tens. We represent that with tens rods. And then lastly is the ones place, 8 ones. Those are typically just little dots. Okay, we can move on from there to number 7. This one is just like we did on 5. We're writing this in word form. We just write down everything we say as we read the number out loud. We have practiced reading a lot of numbers lately. The trick to reading numbers, especially as they get bigger, is read the numbers in front of the comma, name the comma, and read the numbers after the comma. When we do that, we can read this easily. 142, the name of this comma is 1000, 126, and we're going to write all of that down. $142,126, and that is that. Okay, that's everything I'm going to go over in this video. If you have any questions, please feel free to reach out. You can message me on school status. You can send me an email. My email address is in your child's binder, or you can send a note with your child. Any of that is fine with me.